Hey guys, Andre from High Performance Academy here. Welcome to another one of our webinars. Now today we're going to be looking at one of the common products you'll be using if you want to reflash a factory ECU fitted to maybe a late model Subaru or Mitsubishi. That is the combination of a logger and Mega Log Viewer HD, which we can use to interpret that data. So we're going to dive into that in a few minutes. Before that though, just talk a little bit about what's been going on around the workshop over the last week, and we kind of got to the point where we looked at our calendar and realized that our race season starts in about 7 weeks time. We've got 4 rounds of the South Island Endurance Series. For those who have been following us, you'll know that we haven't really had a huge amount of success with the 1 hour endurance racing that we've been doing in our V8 powered 8.6. In fact, it's been a challenge just to get to the finish line. So we've been aiming for a little bit more reliability for this season, as well as addressing some of the problems we found last season with the car. If we head across to my laptop screen for a moment, one of the things we definitely wanted to work on was our Aero. Again, for those who have been following, last year you'll remember that we installed some, what we referred to lovingly as Ghetto Aero, which was a Trade Me special or eBay special rear wing and a plywood front diffuser, front splitter, which was better than nothing, but certainly not where it wanted to be. So for this season, we have decided to get a little bit more serious, and we've purchased some product from Topstage over in Australia. So this incorporates the rear wing, which I'll just draw in there, as well as the rear diffuser. It doesn't quite look as pointy as it has in Brandon's simple little drawing in Fusion. There is also a front splitter, which we're not going to be talking about today too much more. And one of the challenges here has been how exactly we wanted to go about mounting the rear wing. Obviously, when you've got a rear wing that can generate significant amounts of downforce, the mounting has to be really carefully considered. We see a lot of people where they're mounting rear wings to the trunk lid or boot lid itself, and while that cosmetically might look just fine, it really doesn't work aerodynamically, because the amount of force generated from that rear wing is just going to end up bending and buckling the boot lid. So it just doesn't work how it should. You kind of get semi-active aero because the angle of attack of the rear wing is going to be constantly changing. So this is why Brandon's been designing some proper mounts for that. We've looked at a few iterations of this, whether we're going to go in through the top of the boot, whether we're going to come in through the rear like this, which is looking like what we're going to be doing. There's some advantages in doing this and actually mounting the wing further rearward as well, but a few complexities around the airflow over the wing to consider as well. I'm definitely not an aerodynamicist, so we had a meeting today with Topstage to just talk about their recommendations, as well as making sure that we control aspects such as the ride height of the car so that the underbody actually works how it should. So at the moment we are mocking this up, and I can assure you that in its final form we're not going to be using timber for our mounts, but we do have a joiner friend across the road from us here who has a router, so it's really simple for him to take Brandon's CAD model from Fusion 360 and then generate these sort of mock-up mounts so that we could actually test it out, see how it's all going to fit, where it's going to mount, and then look at our options. Straight away we've actually decided that we are going to need to make a few changes to this. It's not going to quite work how we want just now, so we'll be looking at version 2 of this. It's also worth mentioning here, much cheaper to be working in a material such as timber for a mock-up like this and then make the final product CNC machined out of alloy, rather than doing it in alloy, finding out it's not going to work, and you're actually ending up throwing away some pretty expensive componentry that you've made. Now, along with this, there are a few other considerations though. When we've got a downforce package that could potentially be producing somewhere in the region of 1,000 kilograms of downforce up above 200 kilometers an hour, that's significant, and we do need to consider the effect on the suspension. In particular here, one of the first considerations we've got is we are a little bit under-tired on the car. When we purchased the car, it came on a 17-inch wheel, and we had 3 sets of the 17, so it kind of worked pretty well. We had 2 sets for slicks, and we had a set for wets, and we really wanted to persevere with the 17-inch wheel package. However, we've sort of come to the conclusion that that's just not going to be workable for us, so we are moving to 18. So this allows us to go from a 24-64-17, so it's basically a 240mm wide rear slick, all round. We're square on the setup, so a 240mm wide slick all round. We're now going to be going up to a 270, so not as much rubber as we'd potentially like, but essentially that's the limit until we decide, or unless we decide we want to go wide body, and we really don't want to do that with this particular car. So the 18s will be going on it with a little bit more rubber. And then we need to also consider the effect of that downforce and how that's going to work with the suspension. So particularly on high downforce cars, and when I talk about high downforce, I'm generally talking about the cars that we see at the likes of World Time Attack, where the whole Aero package is absolutely optimized, and these cars are sometimes producing in excess of 2,000 kilograms of downforce. Or obviously nowhere near there, but even at the sort of point we're looking at, we start getting into considering compromises with the suspension, because what we need to do is make the car still work in a low speed corner where we have very little downforce. So we need compliance in the suspension. We're talking here about spring rates really, but we also need to keep the car off the ground at 240, 250 kilometers an hour that we'll see at the end of the fastest straights here at our racetracks on the series in New Zealand. So this can be done in a couple of ways. We can either choose to run a very heavy or very stiff spring, which will work at high speed, but as I mentioned, compromises the low speed mechanical grip. The other option, which we see a lot of the high downforce cars use, is they rely on running onto the bump rubbers and also packers to use at high speed. Now, we've got a couple of problems here. First of all, we don't personally have much experience with running high downforce. We also don't have a lot of time available for testing, and particularly when we're only 7 weeks away from the first round, we know how these things tend to expand to take up the amount of time available. We do have a laundry list of tasks to complete on the car. We're unlikely to get a significant amount of testing in before we actually have to go to our first race meeting. So what we're trying to do here is use simulation to help us, which is where our new staff member comes in. I'll talk about him in a bit more detail in a second, but Tim is going to be running everything through OptimumDynamics, which is an OptimumG product, which allows us to essentially simulate the suspension setup and go through some iterations of different spring rates, packers, bump rubbers, etc. to see at least how the car is going to respond, and then hopefully with that simulation we're going to be able to get the car pretty much into the ballpark from the start. It's probably not going to be perfect, but it's going to be hopefully there or thereabouts, certainly better than doing nothing. So we'll of course be covering all of this with some content in our vlog, so keep an eye on our YouTube channel over the coming weeks. We're probably going to have some pretty interesting stuff coming out for those who are a little bit more tech nerdy like ourselves. For the tech nerds as well, we love sensors, we love data, and we're going to be getting some more data onto the car. So in particular, something that we have been wanting to get onto the car for a while is a set of shock pots like these ones here. So these measure the damper or suspension movement, and these are essential in really analyzing the performance of the suspension system. We can also analyze using a shock travel histogram or shock velocity histogram. We can also analyze the bump and rebound valving of the suspension. There's a few intricacies in doing this. Generally, one of the problems with some of the low-end loggers on the market is that they won't be able to actually log the inputs from a shock travel potentiometer or shock travel sensor fast enough. These generally are going to need to be logged to give us useful data, somewhere between 250 and 500 hertz, so 250 to 500 samples per second. This obviously also chews up logging memory pretty quickly when we've got 4 of those on the car, in comparison to most of the sensors on the car we're generally logging somewhere in the region of maybe 20 to 50 hertz. So it's definitely a big jump up. But of course, the suspension moves very quickly, and we need to capture that. In particular, the shock channel potentiometers and using the shock velocity histograms, looking at basically the rate of change of position. The logging package then calculates velocity, and we can separate the operation of the dampers into high speed, medium speed, and low speed. So high speed damping is basically very, very fast movements, which are generally what we get when we're running curbs or ripple strips, and the dampers need to be compliant enough to allow the car to run a curbing or ripple strip without upsetting the balance of the car. Then we've got our low speed stuff, which is where this is sort of driver input, so as we turn the steering wheel, how the car reacts to that. And then we've also got sort of in between where we're looking at undulations in the road, so it really gives us a broader picture of actually what's going on. On top of that as well, we do have a set of Izze Racing infrared temperature sensors, which are a little bit like this little guy right here. So these are a multi-channel. Off the top of my head, I think these are a 16-channel array. We've got 4 of these going on the car that will be measuring the tyre tread temperature. So this gives us an idea of exactly what the tyre is doing, or how hard it's working in the corners. The conventional way of checking the tyre performance to optimize aspects such as our tyre pressure and our camber rely on using a pyrometer when the car comes back to the pits, which is effective to a point. But of course, once the car comes off a corner, comes down a straight and comes back into pit lane, the temperatures tend to normalize quite quickly across the tread. So this is going to give us a snapshot of exactly what's happening when the car is loaded up mid-corner. We're also going to be using a set of these to analyze our brake performance, and we're going to be mounting one of these on all 4 corners. Generally, in most race cars, we'll see one mounted on the front axle line and one mounted on the rear. However, with our particular car, because it runs ABS, the ABS computer is obviously always manipulating the pressure to each corner of the car based on the amount of grip and whether the tyre is locking or not. And what this actually means, and we found this problem at Ruapuna, one of the rounds last year, what it means is that the amount of braking force being applied on one corner of the car versus the other, so front left versus front right, for example, is not always equal. With a conventional mechanical brake pedal box, I should say, trying to get my words out here. With a mechanical pedal box where there is no ABS interaction, we've essentially got the same pressure being applied to both front tyres at the same time. So we get to a point where if we unload one tyre, it's simply going to lock, but this means that we don't necessarily need 2 sensors on each axle line, and most teams will get away with one. So this will allow us to see exactly what their ABS is doing, and we are hoping that we're going to be able to optimize or get a small improvement in our braking performance as we go through this season as well. On top of that, of course, again, if you have been following, you'll know that we are eagerly awaiting our new engine, which we're going from 4 litres out to about 4.5, slightly revised CNC head package and a slightly more aggressive cam. Ultimately, we're going to be going to ITBs, individual throttle bodies, which will still be dual drive-by-wire, but for the time being, due to time constraints, as well as the fact we did want to baseline the new engine with the existing inlet manifold and single LS throttle body, we're going to be running that at least for the first round or thereabouts, and hopefully switching over to the ITBs a little bit further down the track. So some exciting developments there, and hopefully everything's going to come together pretty quickly. Otherwise, we're going to struggle to make it to the first round. Now, moving on, I did just mention we've just employed a new staff member, so taking advantage of the fact that motorsport all around the world tends to be a little bit up in the air at the moment. We had been working with Tim from the Tickford Supercars race team over in Australia. Tim's actually a Kiwi originally anyway, so he's from up the road in Christchurch, and he's worked for OptimumG, worked over in Europe, and he's also obviously then switched across to working for the Supercars Supercars Tickford team, and he's been there for around about 18 months. So he is a data engineer. He's got a mechanical engineering degree as well. So we're really excited to leverage his skill set, particularly with the development of our 8.6. Tim will be working primarily on our racecraft sister project. So he's about to start fronting a data analysis fundamentals course, as well as an advanced data analysis course. So he's going to be showing us all of the same skill sets that he was applying in his job in the Supercars team Tickford there, as well as how you can use the same skills to your own advantage. So really excited to welcome him to the team, and we think he's going to be a really big benefit to both Racecraft and High Performance Academy. I just want to cover off one of the Instagrams that we put up last week, so we'll just head across to that. And probably no big surprise for many people, but when we're starting to look at making huge power levels, a single set of injectors often struggles to keep up. We get into this situation where if you fit an injector that is large enough to maintain the correct amount of fuel at high RPM and high load, the injector can be so big that it struggles to accurately deliver the smaller quantities of fuel that are necessary at idle and at cruise. So common technique, which we can see here on this 2JZ, is to use two rails of injectors. So simply here, there's two ways of doing this. We can use two sets of injectors that are the same size. Often in the drag world, where the idle quality isn't so important, we can get away with this. Sometimes if you need very big injectors, it can be easier to actually split the injector sizing. So use relatively small size for your primary injectors to give that really good idle quality and cruise control, and then a much larger set of injectors that will be staged in. So in general here, the aim when we're just trying to get as much fuel into the engine as we possibly can is to equalize the injector duty cycles across both sets. So we'll bring the secondaries in higher in the RPM once the primary injector duty cycle might be 60 or 70% or above, and we'll start bringing those secondaries in, and then as the RPM and fuel requirements continue to climb, we'll basically start matching the injector duty cycles across both sets. So when this is done properly with an ECU that has the ability to accurately control staged injection, it's completely seamless, and often there's actually not a lot of work to be required there from the tuner. Case in point there, the adaptronic that we have been tuning on our FD-RX7, the staging in that is actually completely automated if you want to match the injector duty cycles like this. All we need to do is tell the ECU what size injectors are fitted primary and secondary. Needs a little bit more information than that around the characterization of the injectors as well, so that needs to be done properly. As long as that's done properly, we essentially tell the ECU what the maximum duty cycle we want to run on the primaries is, and in fact in the adaptronic it's slightly different. We're basically telling it the minimum close time that the injector must have, which basically gets us to the same situation anyway, and then the ECU will do the staging automatically in the background, so we don't even need to worry about what's going on. So when it's done properly, really quite amazing to watch. So good solution there, as long as you've got an ECU that can support it. And lastly as well, we have just released our latest video today, which is one that we shot at SEMA last year. Obviously electric vehicles are gaining a fair bit of momentum, no big surprises there, and AEM have been one of the first to jump on board here with a vehicle control unit that is aimed at those wanting to do electric vehicle conversions. This particular setup uses a Cascadia electric motor, or actually multiple electric motors, and is controlled with the AEM system. So we talked to John there from AEM Performance Electronics about how the system all works and how you can leverage this in your own projects, because again, obviously this is going to become more prominent as electric vehicle conversions become more and more common. In particular, this car ultimately produces 1300 horsepower, so no slouch. And one of the advantages as well with electric motors, electric vehicles, is the torque control is essentially instantaneous, much unlike an internal combustion engine where there is some latency in our control. What I'm getting at here is that traction control strategies can be implemented incredibly well, and they can be incredibly powerful with electric vehicles. So if you are interested in learning a little bit more about EVs, go along to our YouTube channel. Make sure you subscribe if you haven't already and check that video out. I did say lastly, but what I really meant to say is second to last, because one more thing we've got going on here. I just wanted to bring your attention to the fact that at the moment we are running a 50% promotion off our wiring fundamentals course. So you can see up there the coupon code. Jump on that if you are interested. And the wiring fundamentals course, perfect for those of you who want to jump into wiring or learning how to wire vehicles. So this is something I know that a lot of people are put off by. The fact that a lot of the enthusiasts that we have as members are quite happy to modify their vehicle, maybe make dramatic changes to the suspension setup, get stuck into cutting and welding parts of the car, building their own engines, even doing engine conversions, but the wiring tends to be one area that really puts people off. So if you click on that little link like I've just done, you'll see Zach there will talk you through exactly what is included. The course is $99 US. You can use our interest-free payment plan as well, so you can break that down into 8 weekly payments of just $12 a week, and you can read all about what you're going to learn in there. There is the full curriculum as well. So this breaks down the whole process of wiring. One of the things I think is really important to mention here is that one of the reasons I think that people get put off doing their own wiring is because we can't see electricity, we can't see voltage, we can't see current, and we can't see resistance, and these things go horribly pear-shaped and the smoke escapes. So because we can't see this, it can be a little bit less intuitive to understand what's going on compared to the internal workings of maybe an engine. So Zach goes through and breaks all this down, gives you some simple, easy to understand analogies. You'll learn about the different ways that we lay out our circuit designs. You'll learn how to choose the correct size wire for a particular current capability. You'll learn about fusing. You'll learn about relays. You'll learn about the power and ground wiring, one of the areas that I so often see mistakes coming in. And we've also got some information here on some of the practical skills that you will need, including such as documentation, which doesn't sound that interesting, but one of the sayings we have here at HPA is that failing to plan is planning to fail. So getting your documentation sorted, planning the entire job before you ever break out a roll of wire or the side cutters and wire strippers is critical. Once you've got that plan, it's really easy to work from your documentation. Having that documentation will also mean that at a later point you can come back and modify your wiring harness or effect a repair if required, and you're not going to have to try and figure out from scratch exactly what's involved. So if you head across to our website at hpacademy.com, you will find that little coupon code pop up at the top, which will give you 50% off that wiring fundamentals course. Perfect way to start your learning if you are wanting to get involved in creating your own wiring harnesses. Alright, that does it for our pre-show there. Give me a few moments and we'll get started with our webinar. If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.